Alright, welcome to this week's lecture. So the way I usually start my lectures is I start them with objectives. These are kind of goals that you should have and be able to understand by the end of this lecture. So this lecture is antibodies and immune system, and the objectives for this lecture is by the end you should be able to describe the two types of the immune system, so general and specific immune systems, system responses. That's kind of the first goal. Our second goal from this thing is you should be able to describe or define antibodies. So basically, you know what it is, what is it, its function, and how it acts. And then lastly, you want to be able to relate immune responses, pathogens, so pathogens are things that cause disease, and biotech. So those are kind of the three goals for this lecture: pathogens and biotech. So by the end you should be able to answer these and answer these prompts. So in the immune system, there's kind of the general immune system. So what does that mean? That basically means that you have skin. This is for anything. So it's not specific at all. It's for anything that comes your way. Skin is the physical barrier. And you kind of have other physical barriers. These are things like mucus, sweat, tears, all that kind of like gross snot that keeps stuff out. It creates a physical barrier. In addition to skin, we have responses such as fever. These are, again, general responses that work for everything. Fever, increased temperature, that work in the general immune system. So these are general because it can act on anything. This is in contrast to specific immunity. So specific immunity is the idea that's behind vaccines. It's the idea that you have an inherent internal immune system. And this has a lot to do with memory cells and B cells and T cells. So B and T cells. And these are specialized cells that have to do with the breakdown of foreign particles. And by specific, it's targeted. It means it only looks at that one kind of deal, targeted. It can't protect you against anything, but only a couple different things. So what is an antibody? An antibody is a protein, and it's specifically made by a certain type of cell. It's secreted by B cells. So earlier I mentioned that there's B cells and T cells. One way you can remember is T cells are like Mr. T. They fight close, hand-to-hand combat. B cells are like your Katniss Everdeen, your archers. So B cells release these antibodies. And antibodies are specific. They're composed of a light and a heavy chain. And they recognize something called antigens. And antigens are basically symbols or shapes that tell you it's a bad guy. So here would be this guy's antigen. It recognizes the triangle and it binds to it. Antibodies are great for recognizing things, and that's kind of how they're used in the biotech concept. They recognize, they find out. So they basically seek and destroy. So these antibodies, what they do is they fight pathogens, and the way they do that is they can cause clumping, and that allows everything to kind of be in one spot. It can cause identification, and many other ideas. But the idea is that the antibodies help to fight pathogens by locating them and putting them together. So what are some different pathogens that might be out there? So the first one is bacteria. A little bit about bacteria. They reproduce rapidly and asexually. they essentially are clones, so for mutations. Something else interesting about bacteria is they can have a plasmid that can give them extra genes. So plasmids can lead to things like antibiotic resistance. That's something that we need to worry about as you're coming up with your game plan for treatments. You don't want to really develop antibiotic resistance, and that's something that you have to worry about when you're using bacteria. And that's directly related to antibiotics in agriculture, because you're creating these superbugs that no one can cure. And bacteria, again, they're fought by pathogens, these antibodies, identifying them and labeling them from destruction. In contrast, we have viruses. You might recognize a virus, looks something like this. Legs. Viruses are non-living. They require a host. And so the host cell does all the work. It does all the housework. It basically does the copying, cloning, and building of the virus, which then the virus will then release and lyse out of the cell. So in terms of antibodies, these can also label, but they're not as effective. So this is a lot of times when you're trying to test to see if you have it. So if you've ever gotten a TB shot, a TB test, trying to find if you've ever been exposed. It's the same idea for pregnancy tests. You create an antibody that binds to something. And so that kind of comes to our final one, is how does biotech come in? So there's a couple different realms we could go in terms of research. We've got the antibodies to identify. Identify, collect, extract. This is the idea behind column chromatography, that the antibody will grab stuff and prevent things from happening. As you have something that outcompetes it, then the antibody would release the factor. And so that would be the idea. You could make a column, the antibodies, and they could then grab your protein of interest. It's very useful for tests such as ELISA, the sandwich method, which we'll read a little bit more about in your book. But the idea is that antibodies act in terms of separating for research and practical reasons. Another reason why biotech might come in is in the development of medications, which directly relates to your guys' product. If you know what it looks like, what the active compound looks like, you can use the antibodies to activate the nervous system. And that's kind of the biggest things going on right now, is if we can activate your nervous system to detect cancer on its own by saying it's got an antibody. So the antibodies will activate the immune system even though they're traveling not so far. The other way that you can use these antibodies are in testing. So if you've ever been exposed to disease, they're really good for ID, again, to find out if you've been exposed. And that's really important for maybe an immune action plan. You need to have a test to find out if it's present or if it's affecting anybody. So at the end of all my lectures, I usually like to do a little summary, and this kind of wraps up everything that we talked about. Maybe you're in a rush, you just watch the beginning and end. But in summary, just a couple things we want to remind you about. Immune system, what is it? What is it? What are its parts? So learn first about the immune system. From there, we talked about antibodies, which are secreted or released by what type of cells? No, not Mr. T cells. We're looking at B cells. And this has to do with active memory. And so active memory is then going to be linked to vaccines, and why it's so important that every year you get a flu shot if you're one of those compromised populations. And last week we learned about the relationship. So antibodies can be used to identify proteins of interest. and that's really useful for isolation, for abstraction. Antibodies can be really expensive based on how specific they are, but the idea is that antibodies can be used to identify proteins of interest for future use, such as in extraction or biogenomics. So that wraps up what I was supposed to talk about today. Again, antibodies in the immune system. Feel free to peruse it, watch it again. Otherwise, in the future, we'll be hitting some more topics in the same format. If you don't like it, give me some feedback. I'm always open to help out and change things. So, hope you have a good one, and take care. Have a nice afternoon, evening, morning, good night.